All right, so welcome to the easy-peasy-lemon-squeezy statically typed purely functional programming workshop for all. I have two confessions to make. One, I did a version of this workshop last year at last LambdaConf, and I had thought I had prepared enough material for 2 hours. And 2 hours into it, we had covered maybe a fourth of what I wanted to get to. So we may not get to the end. You may never see the end of this workshop material. However, I have made a lot of improvements, so I think we'll actually make it further this year than last year. And second confession is, well, where did I get this easy-peasy-lemon-squeezy, statically typed, purely functional programming workshop for all name? Well, my daughter, who's 7, comes home one day and starts telling me about how things are easy-peasy-lemon-squeezy, Dad. So I just thought that was so cute, I had to stuff it in this workshop title. This is a workshop for people who either A, want to learn functional programming, or B, want to learn PureScript, or C, want to do a little of both. So in this workshop, you are going to learn functional programming using PureScript. So if you already know FP, great, you're going to have an easy time. If you don't know FP or PureScript, that's fine because it is designed for people who don't know either. In fact, I see my wife back there, and she is a recent convert to programming, having only gone through the first 4 or 5 chapters of haskellbook.com. So she's definitely beginner level, and I'm so happy that she made it here today. So hopefully everyone is reasonably set up because this is going to be very hands-on. And if you don't have something to type while I'm talking, you'll probably get bored and take a nap, which is fine too. There's plenty of room in here. Well, let's go ahead and get started.
John, I got one question.
Yeah.
So I've got a no harmony can't run these options. Yeah, I'm seeing it.
I'm getting them.
Post install on PureScript. Are you Mac?
Unfortunately, a lot of people got that error message yesterday. So if you look into general or random, there's actually a workaround that someone pinned. Or actually, it might be the other room. It might be A108 or A104. But at PureScript I tried to get people set up, and a lot of people were running into that harmony error. That is a relatively recent error, and I'm not sure what's going on there, but there was a workaround available for it that someone posted in there. Yeah.
If you add at next, that's right.
At next. At next. So that's a command line argument you need to add?
Well, it's the name at next. And can you post it into the PureScript chat?
Yeah, can you post that into A114? That's this room, right? Or A115? 115. Yeah, so post that into A115, just so everyone has access to that. And please, if you're still getting set up, if you're getting your PureScript environment set up, that's fine. Go ahead and do that. The first few slides are going to be fairly easy, so hopefully you'll just absorb that through osmosis while we're getting set up. And again, if you arrive late, just head on over to that LambdaConf, github.com/LambdaConf, go into the 2016 repo, and there are instructions there as well as files you can download for once we begin the actual workshop. Because once you get your computer set up for PureScript, that's great, but you don't want to code this thing by hand, so go ahead and download that chunk of code. You can actually just click on download, and it will give you an option to download it as a zip. And once you get that as a zip, unzip it, open up a terminal window and cd into that directory. And once you cd into that directory, then like the instructions on the README say, you can build it with some command. It is pulp browserify greater than game.js.
So the bulk build doesn't work. We say yesterday I was there in the PureScript conference and I got over the harmony hump. Now bulk build doesn't work. So essentially it's complaining about unable to pass foreign module game.js.
Might have to blow away some old files and make sure you're updated to the latest repo version. Actually, that's a good question. Let me make sure I didn't change anything. No, that's totally clean. So you could try run. Let's see here. Oops. Unknown module prelude. Well, so if you get an error like that, that probably means you need to Bower install first. Let me try run.
Okay, so I get this.
A bazillion warnings. I get a bazillion warnings and a success.
Well, I have an error. Subcommand terminated. But I get the web page though.
Well, if the web page doesn't do anything, then it's probably broken. You should only get warnings, and you should get a build successful message out of it. And I'm using PureScript version 0.8.5.0. If you by chance have an old version of PureScript, that might explain some trouble.
Yesterday, whatever we installed.
Oh, that's fine. That's the latest.
Not sure what it is.
So let me just type out the commands necessary so you can see this on my screen. Have to download Node.js, then type in node, or rather npm install -g npm. That'll update Node if you want to do that.
We have the latest version of Node. We have Node already installed.
Yes.
That's
5.7, so that's not the latest. So it should work with an older version.
I have 6.2. I don't know if that matters.
But that should work, I would think. So npm install npm, and then npm install -g Bower to get Bower. That's one of the things you need. And then pulp is another one of the things you need. And then after you do those, do PureScript to get the PureScript compiler. After you do all that, you should be able to do something like PSC, which is the PureScript compiler, and do --version and get back the version name 0.8.5.0. Or at least some people getting that to work? Okay. And then when you type in run, if you're on a Mac, I don't know how to do this on Windows, but on a Mac, that should build it. It should stuff it into a file, and it should open up the browser, and you should see this. And you should be able to type things like, look, and get an error.
So you don't need to be able to run or just pulp?
No, you should be able to do pulp browser define into game.js. That looks correct. And I have no idea this was working yesterday.
Did you write all field?
What's that?
All field.
What the heck is going on? Let me just make sure this is using the right.
Maybe that's right.
This should be correct. Well, now you can sit here and spend 2 hours debugging my bad code with me.
Best workshop
I feel the love. Yeah, that's a good idea.
And that might be working.
What? And now it's working like magic. Ta-da! Apparently opening the console will make it work. Let me just verify that. Well, let me try it again. Maybe my browser was caching an old version of game.js. That's the only thing I can explain. Has anyone else gotten this to work? What? Okay. Apparently I'm the only one struggling to get my own program to work.
Use Linux.
Use Linux, yes, I know. Convert to the dark side. Okay, so look, this is a really cool game I built that you're going to help me add features to, because right now it's a really boring game. So you can look around, and you're standing nowhere with nothing around, and we can we can take this bottled water, and there's no water to take, and we can drop the bottled water, and we're not carrying water. And that's the only thing that you could do. So, not very fancy, but I promise by the end of the workshop, if we have a little luck, we're going to make this a lot more interesting. So, and again, if you're still struggling to get things building, use that chat room because other people are paying attention, other people in this room, and they'll be able to help you. Okay, here we go. So functional programming is all about functions. And in a language like PureScript, it is only about functions. So one of the most amazing things about functional programming is that you can build any kind of program in the entire universe just by taking functions and stitching them together. And out of functions, you build bigger functions, and then you eventually end up with the program. And you actually learn that later on if you stick in the beginner track when people cover the lambda calculus. But it doesn't take much to be able to have all the richness that we take for granted in programming. You only need a few different things. It turns out a function is really all you need to build the whole world on top of. And there are some really nice things about functions that make them easier to reason about when you're writing software. First off, a function is a mapping from two different sets. One of these sets is called the domain, and one of them is called the codomain. And a function associates with every element in the domain a corresponding element in the codomain. That's what a function is. And that's the definition. That's a mathematical function. That's the one that you probably heard and forgot back in high school or whatever it is they first taught you these things. And that's all a function is in functional programming too, in purely functional programming. That's what a function is. So here I've described two sets. One, the domain contains eggs and coffee. And in the codomain, it contains happy face, neutral face, and sad face. And this is my own sort of personal mapping of preferences. Eggs make me very, very unhappy. In fact, if there's a piece of an egg in something like a wrap, I can taste it and I will spit it back out. That's how much I hate eggs. Genetically born that way, I guess. Coffee, on the other hand, I love coffee, and I will tell you about every coffee shop in Boulder if you want to know. Or you can come with me on a coffee tasting on Sunday if you want to experience some of the coffee that Boulder has to offer. So I've created a function that represents my preferences. And we apply eggs, we apply that function with the value eggs, and we get back unhappy. We apply it with coffee, and we get back happy. That's what a function is. It seems pretty simple, right? I've explained it to my 7-year-old daughter, and she gets it. That's what a function is. On the other hand, you try to explain a language like JavaScript with all of its warts and like all of its exceptions and edge cases to someone who is 7 years old, and they're probably not going to get it. It's just too complex. This is my John function. It maps eggs to unhappy and coffee to happy. And I'm going to show you what the PureScript code for that function looks like. This is your first taste of PureScript. And if you like, you can go ahead and type this out in that file. So in that game.purs file, you can type this out and get it to compile. Or if you like using REPLs, the syntax is a bit different, so you have to play with it a bit, but you can go and enter PSCI, that's the REPL for PureScript, and that will allow you to enter little snippets, and then it will evaluate them and check them and tell you if there are any problems and spit back out what they evaluate to. And if you don't even want to do that, if you Google try PureScript, there's a web page where you can enter in PureScript snippets and compile it online, so you don't even need anything installed. And if you want to try some of this stuff while I'm going along before we get to the first set of exercises, that's a great idea. So this is what PureScript is. Remember I said that a function maps from one set called the domain to another called the codomain. Well, in programming languages, sets are called, sets of things that you map between are called types. So if you're wondering what a type is, it's just a set of values. And PureScript allows us to construct these sets with the data keyword. So in this particular example, I can construct a set that is a type called food. And what is food going to be? Well, it's going to be either eggs or coffee. And that pipe sign you can read is either. It's how you construct a sum type in PureScript. And it can be read as either. So I'm going to construct a new type here that is a new set of values called food. And inside that set is eggs and coffee. So this literally reads like the image showed you in the previous slide. What is food? Well, food is just a set that contains eggs and coffee. And similarly, I'm going to construct a new set called happiness. And this set called happiness is going to contain three things. And those are happy, neutral, and unhappy. So I've constructed here two sets. And I'm going to use one of them as my domain and one of them as my codomain in a function called John. And this is the PureScript notation for defining declaring and then defining a function. So in the first line, I declare a function called John, and I declare it as a mapping between the food set and the happiness set. So you see that little arrow there? If we actually go back to that, I used arrows there too, so you can see how the notation that we would use in a math class for describing a function actually matches the notation we use in PureScript for defining a function. We use that little arrow and we say, John is a mapping from food to happiness. And actually, if you're looking real close, you'll notice that John is actually a set containing one thing, and that is a function from food to happiness. And that could be read as John is a member of the set of all functions from food to happiness. John is an example of a function which maps from food to happiness in a hypothetical set that contains all functions that map from food to happiness. And all of you would be in there and count uncountably infinite number of other functions. Actually, there are only so many different ways you can implement it with these simple types. And that's the declaration of the function. And then how I define that function is using the notation you see there. John at eggs is mapped to unhappy, and John at coffee is mapped to happy. So now if I apply my function John with eggs, it's going to spit out unhappy. If I apply it with coffee, it's going to spit out happy. And is there any circumstance in which it's going to spit out neutral? No, there's no circumstance it's going to spit out neutral. And that's something that we can't tell just by looking at the type. We have to inspect the implementation to tell that. But that is valid in math. It's valid to have a function that doesn't map everything to something in the codomain. However, it is not valid for us to try to create a function that doesn't handle one of the things in the domain. And in fact, if you tried to compile this and you delete one of those lines there, like John of eggs is unhappy, then the compiler's going to complain. It's going to say, you didn't handle something in the domain. You mapped coffee, which was one of the things in the domain, to something in the codomain, happiness, but you forgot to map eggs. And so you have a guarantee, whenever you use a function in PureScript, you have a guarantee it can handle every possible input that's defined in the domain. And that is really, really powerful. Because what it means is you can safely pass it anything that the compiler lets you pass it, and your code is not going to blow up. Your program's not going to explode. You have that guarantee. Pass it anything you like, and you're going to get back a value in the codomain. Yes?
So you use everything in the domain, but you don't have to use everything in the codomain?
That's right. And let's go back to this image here, and you can see what this looks like. This is a function. We are forced to map everything in the domain to something in the codomain, but not everything in the codomain has a corresponding element in the domain that it maps to, if that makes sense. So there's no value there's no food in this set which will map to neutral. Although in real life there are probably foods I don't care about.
Is this slide intended to be like a black background and black text?
Ooh, oh no, there are actually words here that I can see that you can't. Yeah. Hey, you chose the theme. Nope. 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 Ah, there we go. Boring, boring, boo. Okay, fine. You're going to be that way. So once we've defined a function in PureScript, how we apply it, we don't run functions because run implies code, right? And when we're writing a functional programming language, we don't need to think in that way anymore. We can think in the way that we have functions and we apply them to arguments to get back values, arguments in the domain to get back values in the codomain. So how we apply a function called John is we use the space operator. Yes, that's right. Haskell and PureScript actually treat space as an operator. And that means when you use space, you're saying, in general, there are exceptions, you're saying apply this function or this value to this function. And in this example, I take John and I apply eggs to it and I get back unhappy by using that space. And I take coffee and I apply that to the function John and get back happy. So very, very simple. In another programming language like JavaScript, you would use parentheses to apply a function. You don't need parentheses because function application happens so common that, that the designers decided, well, we'll just make it the default and space will apply arguments to functions.
When you said that PureScript treats space as an operator, is it like a block of white space, or do you like start chaining spaces together?
It is any block of white space. So if you have an identifier followed by some block of white space, followed by an expression, then that will always be treated as a function application, no matter how many spaces. Except don't put a new line in there, because languages like PureScript, they're sensitive to white space. So there are pluses and minuses to that. On the plus side, it sort of cleans up your code, makes it a little prettier, but it does mean you can't just add random new lines everywhere and expect things to compile. But why would you want your code to compile if it's ugly? So, all right, here are the rules. Totality, every single element in the domain must be mapped to some element in the codomain. And if your function has this property, it is an actual function. And it's called actually a total function. But that's the definition of a function is, by definition, a function is total. If a function is not total, we call it a partial function, which means that functional programming is either total functional programming or partial functional programming. We're going to do the total kind in this workshop, although there is the partial kind as well. Determinism. And this is the profoundly simplifying aspect of functional programming. Siri, you are not invited to this workshop. Machines are smart enough as it is. They're winning Go and chess and everything else these days. So determinism, applying a function with the same value in the domain must result in the same value in the codomain. What does that mean? It means if I pass foo to my function and it returns bar, that's always going to be true. It's never going to change. You pass some value to a function and it's always going to give you the same value back out. And that, in my opinion, is what makes functional programming amenable to reasoning. Because how many of us have been working in a code base and like there's this function that takes no parameters and returns nothing, and you have to invoke it and it does something and you don't really know what it does until you start digging into the code base and finding out all the crap that it does, and it's just so confusing. And how do you test a function like that? If you're writing a unit test or something and it takes no parameters and returns nothing, good luck testing that. That's what gave birth to mocking frameworks and all sorts of other manner of mostly abominations that help work around the limitations of the languages that we use. So determinism makes testing easy. It makes reasoning easier. You have a guarantee in PureScript that every time you pass a specific value to a function, you're going to get back the same result. And just think about that for a second. If you're used to imperative programming, that's just amazing. Like, that's just mind-blowing. And the function's not going to do anything other than return a value. You apply it and you get back a value. That's it. There's nothing happening behind the scenes. So you can look at that function's type, you can look at its domain and its codomain, and it says it maps between this and that, and you can have some very deep understanding about what it is that function is doing just by looking at its type.
Is there a way to represent like a nothing in PureScript? Like sometimes.
Like no?
Yeah. Is that how would you achieve that? Would that be in the codomain and you can?
In the codomain, yes, exactly. So you would add something in the codomain saying not here, and thus in the type it would be reflected that in some cases you're going to get that not here value, and you would be forced to handle that if you take something out of that a function returns in the codomain and you pass it into another function's domain. Then the compiler is going to make sure you handle that not here value, and that's the same way that you handle exceptions. Because exceptions, what's the bad thing about exceptions? They're really hard to reason about. If they can occur anywhere throughout any of your code, and you can like jump out arbitrarily from any place, no matter how deep, and hop over here because something bad happened, how are you going to know that? You actually have to study the entire code base. Like you have to study, okay, I'm calling this function, dig into there, look at the source. That calls this one, well, dig into there, look at the source. And like you have to exhaustively enumerate all these possibilities in order to see if a function throws an exception. That's nasty. Whereas in a language like PureScript, you look at the type and you see the codomain. And if the codomain has something in it that says not here, which you'll see by looking at the type, then you know that it can in some cases fail to return a value. So that's it. That's what a function is. If you understand that, you are a functional programmer. Congratulations. That's all there is. The rest is just syntax. Alrighty, so let's proceed to our very first exercise set. And if you open up that source file, what you're going to find is I've commented all the exercises and where they should go in that source file. And I just invented locations for them. And I've even gone part of the way and included part of the solutions in there and also in the deck, which you can find the deck inside that repo. So hopefully there's not going to be a ton of work you have to do, and hopefully it's going to be clear where inside the file you're going to have to do it. Once you make those modifications, you can save your file and try to rebuild it, refresh the browser, and see if what you did changed anything. And it might not, honestly. The early exercises are probably not going to change the way the game functions, but we'll get to that hopefully. So let's create a set called character status, which represents the different states of the player. Because this is a text adventure game, so we want our player to be content, maybe hungry, maybe tired. Maybe we'll force the player to sleep if they get really tired as the day goes on, or force them to eat, otherwise they're going to die. So let's just define a new set called character status that consists of content, hungry, or tired. And you can use that syntax and you can put whatever types of statuses you want. You can put 1 in there, you can put 10 in there, it doesn't matter to me. And then let's go on further, and we're going to create a function called describe character status. And I want you to look at the type of that function there and tell me what that function does. What is its domain? What is its codomain? And what is it trying to do? Anyone want to venture a guess? What is the domain of describe character status function? Character status, yep. And what is the codomain of describe character status? String. So what does this function do? Well, we know that it maps every element in character status to some element in string. String is the set of all possible strings. And that's infinite. So now you can see where the definition of a function is actually pretty useful, because function doesn't guarantee that our function describe character status can produce all possible strings. how could it even make that guarantee because it's an infinite set? Instead, what it does guarantee is that our function describe character status will map content to some string, hungry to some string, and tired to some string. So once you create that function, go ahead and implement it. So once you create that little type signature, go ahead and implement it for those three cases. And you can invent whatever you want. And we'll get to the syntax of strings in a bit, but it's just double quotes. So there's nothing fancy there. You can create a string literal in PureScript just with the double quotes. And you can map all these different character statuses to some description. Like, I would map hungry to you are feeling hungry now, or something like that. Or tired as you are feeling very sleepy. So let me run in here real quick. Now that you had a chance to do that, hopefully. And where is that? Here. Okay, so here's exercise set 1. Here's one of 2. Now this is the solution. So hopefully you're all done. Content or hungry or tired. And there's no unique solution to this one. But I'm going to do okay, so that's my solution, and I'm just going to compile it with pulp build successful. Okay, so did anyone have trouble with that? Yeah. Yes, there is a shorthand. Now I'll cover that in a second. It's a case statement. You do describe character status some value v, and that creates a binding to the variable equals case v of, and then you put your patterns and you use the arrow symbol and yeah. All right, so types are sets of values, and let's dig into some of the sets that PureScript both supports natively and allows you to create. So think of these big blobs with things in them. That's what types are. That's all they are. And JavaScript is actually a typed language. What is the domain of a function in JavaScript? What is the domain of a function in JavaScript? Anything. The domain of a function in JavaScript or Ruby or Python, it's anything. What is the codomain of a function in JavaScript or Python or Ruby? It's anything. It's really anything. You can return anything. Yes. Yeah, that too, everything. Anything and everything. And that's why sometimes you'll hear, like, technically JavaScript, Python, Ruby, etc. are not dynamically typed or untyped languages. They're unityped languages. That is, there's a single value, and that value is a sum type that consists of all possible values. There's a single set, and that set consists of all possible values in the known universe that you can construct using JavaScript. And that single type in there is what everything has. So everything has that type, which means that when you look at JavaScript, or some other dynamic programming language, the compiler's not forcing you to do anything. And also all functions are partial in JavaScript, because what happens when you fail to handle a particular thing that is inside the set of anything? Get exception, right? Generally, null pointer exception or some other random exception. So literal types, let's go through these fairly fast. There's string, which is the set that contains all strings. And you create strings with the double quotes, like we've seen. There's number, which is a set that contains all numbers. 5.5, for example, is an element of that set. Int, which is the set that contains all integers. 3 is an element of that set. Char, which is the set that contains all characters, and you do single quotes to create one of those, literally. Boolean, which is the set that contains exactly two values, and they're called true and false. And then there's records and arrays, which you can construct using a notation that should be familiar to you if you know either JSON or JavaScript. Man. Okay, so did everyone get those little types? It's sort of what you'd expect and what's in other programming languages. Yeah.
True, false, or lowercase in PureScript?
Yes, it's weird. Yeah, people complain about that all the time. All right. So, product types. And you don't really have to understand where they get the name, but it's basically a product type is the type that we've already seen, and they're introduced with the keyword data. And you do data, and then you do some name, some identifier, and in PureScript it has to start with a capital letter. So all types, remember a type is a set of value, all types start with a capital letter. And you name that right after the data keyword. And we've already done that, so it shouldn't be that difficult. And that equals sign is nonsense, utter nonsense. It's one of the things I wish they would change about PureScript and Haskell, because that equals sign does not mean mathematical equality. It doesn't mean that at all. So I don't even know why it's used, other than historical legacy reasons. And then that second loc over there, you'd say, why is loc being repeated? And this will sort of make sense in a bit. This looks a bit different than the other stuff we've seen so far. But the reason why that loc is being repeated is it's actually the name of a function that will create values of the type called loc. So remember, loc is a type, it's a set of values, but how do you create things that are inside that set? Well, you do it with a function, and that function is called a data constructor. And that data constructor will allow you to construct things inside the set of loc. And the name of this data constructor happens to be loc, which is the same as the name of the type. Does that confuse the compiler? No, it does not confuse the compiler. The compiler has separate namespaces for types, that is sets of values, and functions, and other types of values. So those are totally separate, and the compiler is not going to be confused by that. We're more likely to be confused than the compiler, because now we've got a type running around that has loc, and we've also got this function, which is a data constructor called loc. But keep in mind, those are two different things, and I didn't have to name that data constructor loc. I could have named it location, or whatever I wanted. Those two don't have to be the same. They are just the same in practice rather than by necessity. All right, and there are two constructor parameters because everyone knows a location has two parameters. You have your x and your y, your lat and your long, or if we're doing a game, we probably have some sort of grid in which the user can travel to adjacent grid points. So those are parameters, and you specify the types that can fit in those slots. So this product type has a data constructor called loc that has two slots, and each of those slots must be integers, which means when we call the loc data constructor to select for an element in the set of locations, the compiler is going to want us to specify two integers. We're going to specify two integers, and then our data constructor will do as a data constructor does and construct some data. Okay, how does that look in practice? Well, where am I equals loc1, 2. And that constructs us a location where the first parameter is a 1 and the second is a 2. So this set of location is actually, an infinite set. Well, it would be if int were infinite. But it contains all things that have the shape, the structure of loc, and then some integer and then another integer. It's the shape of everything inside that location set. So really, these integers, they're creating basically holes, and that's totally fine. These are called product types because the number of possible states is equal to the product of the states of every element in the product. This thing has two components. It has a latitude and longitude, or x and y. So the number of possible representable states are the number of ints times the number of ints. That's a Cartesian grid, and that's the number of possible states in your map. So if integer only had 10 slots, for example, you would have a 10 by 10 map with 100 elements, And that's why these things are called product types, because they compose like products, like multiplication. So this is how we construct, but one of the things functional programming is known for is not just constructing data, but deconstructing data. It's very simple to deconstruct data. That is, once we have something that's in the set of loc, we can peel out its x and y components to know where it is. So once we've constructed a loc, we can also deconstruct it and get back the ints we used to construct it. And you do that with pattern matching, which is also called deconstruction. And pattern matching allows us to pull out the components of interest to us. So in this example, I create a locx function, which maps from a loc to an int. How do I do that? Well, to deconstruct, you use the same syntax as construction, except in each of the slots in your product, you're going to specify a variable name. And if that pattern match succeeds and the compiler says, yeah, that was the right pattern, it's going to pull out the thing in that slot and it's going to assign it the specified name. And then over on the right-hand side of your equal sign, when you're defining the function, you may use that name, and that name refers to the thing that was in that slot. So in this example, I use the underscore, by the way, when I don't care what it is. But I could do loc xy of loc xy equals x times y, or something like that. I could refer to both things in those slots. So takeaway for this is the syntax of deconstruction / pattern matching mirrors the syntax for construction. Only instead of like feeding things into it, like feeding values in, you're getting variables out that you can then use on the right-hand side of that equality. Does that make sense? This is, I've never seen a language like Haskell or PureScript, and I understand how this concept would be confusing. Some examples would help, but does that sort of make sense? Anyone have any questions about that? Okay. And here's another way to deconstruct, which is going to also, you can use this you can't, but this is another way to deconstruct stuff. So you use the case statement, and the case statement allows you to, it's similar to case statements in other programming languages. You stick the expression between two keywords, case blank of, and you stick the expression in the blank. And then what's going to happen is you're going to be allowed to repeat all the patterns below that, all the different constructors. You're going to have one constructor or one deconstructor, one pattern for every constructor that you had in the declaration. The compiler will force you to do that. And then you're going to have the opportunity to deconstruct these things / pattern match and pull out what you want and return something for every one of the cases. So this may seem annoyingly verbose for now, but you'll see when we get to some types how this style is actually more compact. All right, well that's enough presentation. Let's jump into exercise set number 2. So number 1, I want you to create a character stats product type to model some character statistics in a role-playing game. So my example, I've chosen health and strength because we want stats to reflect how healthy is the player, or maybe like a non-player character like a monster, and how strong are they, so when they fight it out we can tell who wins. So go ahead and create that character stats product type, which is going to end up modeling that. And now I want you to create some values of that type to understand how to use data constructors. And an example that I've used here is starting stats. So maybe we use this value when the player starts or when a monster starts or something. And this is what they start at. So maybe they have health of 100 and strength of 100 or something like that. But create some values using that data constructor. And finally, I want you to introduce 2 functions, or n functions, where n is the number of elements in your product type, So if you had character stats and you did like a int and a string and an int, then that's 4 things in your product. It's a 4-way product. And I would want you to define like 4 functions. And every one of those functions, I want you to create a function that extracts out that component and returns it. So in my example, I've said, well, let's create a health of function, which given a character stats is going to return an integer. That's the first thing in the slot, in the 2-way product slot. And strength of, which is going to return the second thing in the slot. So it's going to return how strong our character is right now. And in order to do that, you're going to have to use deconstruction. Just like in order to do starting stats, you have to use construction in order to define these 2 helper extractor functions, you're going to have to use deconstruction. All right, so this is the section here in the code. The starting stats we're going to use the constructor called starting stats, or called character stats. That's a constructor, and how many slots does our constructor have? It has 2. It's a 2-way product, and we're going to give it 100 health, and we're going to give it 100 strength. And now we have to define 2 functions, one to extract the health out of character stats. And then another one down here to extract the strength out of the character stats. Whoa. Error by copy paste. And let me just compile that before I say it's done. Okay, it's done. Oh, two example extractor functions. So here, this is the type that introduces the type. This is a constructor. It's a function that will construct values of this type, which are coincidentally named the same thing and exist in different namespaces in the compiler's view. And this is my starting stats, which is a value of character stats type, which I construct by using the data constructor and giving it one thing for each of the things in the 2-way product. And then this is an example of deconstruction. I'm using pattern matching here to say, well, this is character stats, and this is the first, and that's the second. I'm going to call the first health, the second strength, and then I'm going to return health, which is the thing in the first slot. And down here, I'm going to return the thing in the second slot. And notice I don't use strength here, so you could just use underscore if you don't care about the name. Saves you some typing, and it looks a little better. All right, everyone get that? Okay, so let's go into sum types. So sum types, product types represent an and relationship. So for example, an xy point has an x coordinate and a y coordinate. Sum types represent an either relationship. So for example, a non-player character is an ogre or it's a wolf, or a shape is a rectangle or a circle or an oval or a triangle. So these are the 2 fundamental types of data in any programming languages, although some don't acknowledge the existence of some types. They're there too, and they're super useful. One says and the other says or. And they're incredibly useful in functional programming. You're going to use these all the time, even though in some other languages like Java you would almost never use them. And they get their name from the way the state spaces compose, which you can work out on your own. Let's break them down. So as before, data and then the keyword, that's the name of the type. And then as before, these are the names of the data constructors. But in this case, there's more than one data constructor. That means there's more than one way to get an NPC. You can construct one using the ogre constructor, or you can construct one using the wolf constructor. And even though they require the same things and they're both three-way products in this example, those constructors, that's not necessary. And in general, the different constructors can have any number of parameters, from none to a bazillion. So in this particular example, these data constructors have 3 parameters. So when you, to build an NPC that is a wolf, you'll need to supply 3 things. To build an NPC that's an ogre, you'll also need to supply 3 things. And there's the name of it, its location, and I don't know, its strength or something. And look at how that syntax scales. That syntax scales as follows, and this will bring us back to the very first example I showed you, where the compiler is going to, when we create a function called nameOf, for example, which is going to give us the name of an NPC, and therefore has type NPC to string, it's going to map from a non-player character to its name. We use the deconstructor syntax, the pattern matching syntax, to pull out the name. And the same for the wolf, we pull out the name. And so we're able to deconstruct these NPCs based on what type of NPC that they were, and pull out the elements of their products that are relevant to us. And now if you go all the way back to the slide number 1 where we define the John function, you'll sort of see the parallel with that. These are much more complicated sum types because they're sums of products. And that's the fundamental representation of data in PureScript is this sum of product thing. So we are exactly halfway. So we're going to take a quick 5-minute break. So get some coffee, use the restroom, drink some water, whatever you like. And I'll also take questions during the break.